Hi everyone, and welcome to this presentation. I'm so excited today to share with you what we are doing at Deep Flows and how we vision the future of our cities from a transportation and mobility perspective. By the way, I'm Mohamed. I'm the co-founder and chief executive of Deep Flows. I'm also a civil engineer from EPFL with a background in traffic engineering. We have a lot to cover today, so let's go. Did you know that we are living a historical moment? It is the first time in history where over 50% of humans live in urban areas. Urbanization rates are growing fast. So are cities. At the same time, transport demand is skyrocketing, and its emissions are pressuring the environment. Road transport for itself is responsible for 15% of global CO2 emissions. But not only that, it also became the source of a costly, growing, popular, frequent, urgent, and mandatory to solve problem, which is traffic congestion. Cities have been spending millions, to not say billions, to solve this problem for a long time. This is how traffic management was done in the 80s. So cities send traffic surveyors to the streets counting vehicles. They count how many cars, buses, pedestrians crossing the roads. After the count, they hire engineering companies to make congestion maps. Then they design a new traffic light plan, program a traffic light controller, which is connected to the traffic lights, and then repeat the process every 3 to 5 years. Now, do you know how traffic is managed today? So you get the count, the congestion map, the traffic light plan, program a controller, and connect it to the traffic light and repeat the process. Pretty much the same, isn't it? At the same time, the transportation and mobility sector is getting shaken in all directions. Not only one, but 4 revolutions are happening at the same time. The sharing economy, automation and electrification of vehicles, and adoption of new micromobility modes are reshaping how people are getting from A to B. As you can see, demand is changing fast, super fast, and supply is static and adapting very, very slowly. Sorry here, I have bad news for you guys. Cities are still stuck using the most outdated tools to make billions of dollars decisions with our money. They don't have the right data to make the right decisions in order to contain congestion. Another interesting aspect of transport demand is that it is stochastic. It means that it is very hard to be precisely predicted. It can look like this. And this is how supply looks like. So if you use first principle reasoning, congestion is happening when demand is superior to supply. If we continue solving traffic congestion as we used to, things won't be getting any better. By the way, a few years ago, we came across a startling statistic from the World Bank saying that African urban population will grow 100%, jumping from 500 million today to 1 billion in 2040. So we decided to come up with a business plan that makes sense in this context of mind-blowing growth, to design sustainable cities for us and future generations. So we created Deep Flows. Our vision is to become your city's traffic operating system. It's like Microsoft for your computers. So we will achieve this by fusioning data from multiple sources and creating a digital twin of our road infrastructure network. We are also developing intelligent systems that will help cities make the best decisions to manage traffic, reduce emissions, and save lives on our roads. So let's go through some applications of machine learning in road infrastructure. At Deep Flows, we use computer vision to access traffic data like vehicle flows, road densities, and speed of vehicles. Why computer vision? Because it is the most deterministic approach to capture what's happening in the physical world. So today we are developing a SaaS for city planners to help them transform traffic videos into data and insights. Our solution is faster, better, and cheaper than legacy manual counting methods. We use state-of-the-art algorithms like YOLO V5 to achieve very high accuracy and efficient performances. See how powerful it is to identify, track, and classify different moving objects in a complex scene like this one. With computer vision, we have cities better designed cycling infrastructure to support the cycling boom development. For instance, we can monitor demand in order to rapidly adapt bike lane supply to the growing traffic. We also do traffic volumes classification to estimate emissions based on vehicle categories. In order to implement safety policies, computer vision helps us extract vehicle trajectories and speed to understand bike-vehicle interactions. And last but not least, a very fundamental measure to assess a policy impact is to measure modal shifts. In other terms, we compare traffic volumes classification before and after a policy implementation to assess the impact on transport model choices. So let's see how we use data vision now and machine learning to estimate the total number of vehicles in a network. We will use data from cameras and probe vehicles. Probe vehicles can be taxis or connected vehicles, sending anonymized GPS information. Cameras will provide us data like vehicle flows and road densities. Probe vehicles will send us data like distance traveled and probe vehicles flows in precise location. So we developed a methodology based on the expectation maximization algorithm to fusion these data and estimate the total number of vehicles in the system. And for that, we only need 3 to 5% network coverage with cameras and 3 to 5% vehicle penetration rate to get accurate results. And why do we want to measure this? That's a good question. To answer it, let's talk about active traffic management first. So here, let me introduce you to the MFD, the macroscopic fundamental diagram. In fact, road networks exhibit an intrinsic characteristic called the MFD that links N, the total number of vehicles traveling in the network, with P, the production of the system, measured by the total distance traveled by all vehicles in a given period. This is a network peak hour simulation in Barcelona. Notice how the production of the system increases as we move in time, as more vehicles enter the network. After a given point in the green region, as you can see, the production starts dropping as the number of vehicles increases. Here, we enter the system congested state that we all hate. So our goal here is to maximize the network production. So our strategy is to maintain the system at this sweet spot in the green area, which is given with an optimal number of vehicles not to be exceeded, and opt for optimal. And that's what we predicted in the last use case, if you remember. This strategy is called the perimeter control. It consists on creating a perimeter delimited with traffic lights, prioritizing traffic outflows in green over traffic inflows in red arrow to keep the system in a non-congested state. This strategy is very powerful. It reduces travel times and increases productivity of the system. It has been proved that more pollutants are pumped in the air when vehicles are cruising for parking or stuck in traffic, accelerating, decelerating, accelerating, decelerating. So keeping the network in a non-congested state prevents that. And what is also beautiful about this strategy is that cities can enjoy all these benefits without building 1 meter of roads. And as a consequence, they can make savings on road construction budgets and prevent this from happening. This is a really sad image of a new highway crossing right in the middle of a residential area in Egypt. In other words, authorities are saying let's postpone the problem in 10 years later, because obviously there will be congestion there, no doubt about it. So to prevent this from happening in the future and make our vision a reality, there are some challenges that we encountered when we launched in Tunisia. So here I wanted to share some of them. So when it comes to the technical challenges, finding the right data to train our machine learning models isn't always very straightforward. We found that some vehicle categories are typical to the Tunisian market. And here I join Mr. Tawfiq Jlassi when he said during the opening keynote this morning that most machine learning models are built on data sets from the US and Europe. So our duty here, so we have to find out how to collect African data sets and label it to train our models. Also, a challenging task is to detect and classify vehicles under low light conditions, for instance, during night, because public lights are not always on duty, unfortunately. And when it comes to data fusion, connecting devices and fusioning data comes with a consistent level of complexity involving edge computing and strong communication networks, which are difficult to access sometimes. On the business side, we found out that educating customers about machine learning first principles and capabilities is crucial in order to align our expectations so they know what can be achieved or not and in which time frame. When it comes to recruiting, African machine learning engineers are a scarce resource because of brain drain to more mature markets. And last but not least, when doing business with the public sector, one should be aware of the importance of good governance. Our experience in Tunisia showed us that decision-making is very centralized and local authorities should invest more efforts towards decentralization. But despite all the challenges, opportunities are still here. Here are some projections of the future African megalopolises. Today, we count 3 cities with more than 10 million of inhabitants in Africa. And in 30 years, this figure will rise to 14. Transport infrastructures are the backbone of every economy. Investing to create the road infrastructure digital layer is crucial. It is an important precondition for performing intelligent transport services. Graphically, this can be represented as something like this. Over time, services are being rolled out which contribute to more performing smart transport infrastructure systems. And getting the digital layer right is a precondition to having the services function. This is a typical path dependency problem. To bring to reality advanced traffic management services, to make our cities more sustainable and livable for us and for future generations. And I would like to end this presentation with a quote from the great British physicist, Lord Kelvin, saying, "If you can't measure it, you can't improve it." And that's what we believe in at Deep Flows. So I hope you enjoyed this presentation and it gave you a better sense of why it is important to measure and understand what's happening on our roads in order to shape the future of road infrastructure. Applying machine learning is opening a large array of traffic management applications in a world where space is becoming a new scarce resource. I will be happy to interact with you during the Q&A or later, so feel free reaching out to connect. Thank you very much.
Thank you, Mohamed, for the fascinating talk. It's very, very interesting. I really like the idea that you have. We don't have questions yet in the chat. Many people are thanking you and congratulating you. I have one question on my side. Do you have already a use case with a city? Or maybe said otherwise, have you been able to evaluate and validate your approach?
Yeah, so our first deal came in last April. So we worked with the National Railway Agency and we collected the traffic data about commuters in Tunis railway station. So we installed cameras during 3 days and we extracted how travelers are behaving in this station. But at the same time, we are talking with the local authorities to join a project on a national scale, so we can help them better collect data, which is still today done manually.
Okay, I see. Thank you. And maybe another question. So, what specificities of Africa make your task more challenging or less challenging? I think you've discussed that a little bit, but maybe you could go a bit more into details.
Yeah. So I will start by less challenging. So as you know, the market is not that mature, and you can go really fast and use this technology on multiple use cases. There is low competition today. We are the first movers in Africa, but at the same time, the fact that the market is not mature and doesn't have sometimes the appetite to consume some technologies, it makes the task very challenging. That's why I highlighted the fact that we have to educate customers about the capabilities of such technology and make them make them have a projection of how we can better enhance their life and the operations with the computer vision.
Okay, thank you. And we have one question from Mohamed, a very good one, I think. He's saying that your customers are currently public institutions. So two questions, actually. The first one is, do they have plans to invest in mobility? And the second one is, have you identified customers in the private sector?
So, yeah, thank you, Mohamed, for your question. So today, our customers are both. We are in the B2B and the B2G space. So as I mentioned earlier, the project in where we were involved, our customer was a traffic engineering company. So we are doing B2B here, and our customers are working in the B2G space. So we intervened as a subcontractor in this project. As you know, sales cycles are very, very long in the B2G space. So today, if I want to talk a little bit about the business approach, so our go-to-market strategy is by penetrating the market with the B2B space. So we can build a portfolio of projects with our customers, and then we'll be moving to the B2G space.
Great, very interesting. Thank you, Mohamed.